This is Talk of the Nation Science Friday. I'm Ira Flato. Later in the hour, we'll be talking about an unconventional view about where oil comes from, and then we'll move on to the Voyager spacecraft anniversary. You're listening to Talk of the Nation Science Friday. I'm Ira Flato, and we're going to be switching gears right now and talk about common knowledge. What were you taught in school about how natural gas, coal, and oil were formed millions of years ago deep within the Earth? Well, chances are, if you're like me and the rest of us, you were taught that these fossil fuels come from the remains of decomposed organic material from prehistoric plants, animals, swamps. You remember the picture, the dioramas from the museums? Well, a paper published in the Proceedings of the National Academy of Sciences this week presents a way that these reactions can take place. The authors managed to make hydrocarbons under heat and pressure, but not using organic material, not with plants and stuff like that, but using solid iron oxide, marble, and pure water. Joining us to talk about this work is J.F. Kenny, CEO of the Gas Resources Corporation in Houston, Texas. Welcome to the program.
Thank you.
Yeah, well, walk us through this a bit. Now, the one theory that we all are taught that says that petroleum is formed from the decomposed remains of ancient organic life. And your theory discussed in your paper recently you published says what? How is oil formed?
Okay. First, dear sir, I must correct you on 2 points here. First, the notion that petroleum originates from some transformation of biological material in the shallow sediments of the Earth is not a theory as such. Certainly shouldn't be called that. It was only enunciated as a hypothesis, but it was enunciated in the year 1757 by the greatest Russian scientist of the 18th century, Mikhail Lomonosov. That's the biological hypothesis, and certainly Lomonosov never intended it to be more than a hypothesis. That's 18th century Russian petroleum science. What you have received a small taste of in my article in the Proceedings of the National Academy of Sciences is a small taste of 20th century Russian petroleum science.
The author certainly
I emphasize this because your phrase, my theory, is terribly incorrect.
Well, your name's on the paper, so I mistakenly, I don't think mistakenly, you do quote, and your colleagues certainly are Russian scientists through the paper, but your name's on the paper too.
Yes, but you should understand, in fact, the modern Russian petroleum science was first enunciated in the year 1951. And to take a half step back, you should understand that in 1946, the then Soviet government was confronted with two uncomfortable facts. The first was that to wage a modern war requires enormous amounts of petroleum. That was point one. Point two, Russia was a petroleum-poor nation. At that time, they had only what they believed to be the depleting fields in the Ashkelon Peninsula near what is now Baku, in what's now the modern independent nation of Azerbaijan, and the newly discovered fields in Turkmenia and Tatarstan, which turned out to be enormous fields, but they didn't know it at the time. The Soviet government initiated a Manhattan-type crash program to learn about petroleum. Where is it? What does it come from? How do you find it? And so on. And out of this program came the enunciation by the great Russian geologist Nikolai Kudryavtsev, the modern Russian, what's now called the modern Russian-Ukrainian theory of deep abiotic petroleum origins. That's what you've read a taste of.
Well, let me give my listeners a taste of the article. And the article says that basically these scientists were able in the laboratory to take basically rust, right? Iron oxide. Rust, marble.
Exactly what it said. Nothing but iron oxide, which of course is a solid.
Right.
Marble. Just like you got it right. Calcium carbonate. Wet with triple distilled water. They brought it up to the enormous pressures that you find in the mantle of the Earth. I say there's a bit of back, and then out came oil. You could take it and put it in your gas tank and drive home with it. And that's all there was in there. There was great care was taken to make sure there was no contamination and no No.
Well, yeah, that's enough. Yet this theory is certainly not widely accepted by everybody. They say that.
No, excuse me, sir. May I correct you right there?
Go ahead.
On 2 points. The fact that oil does not come from squashed fish or putrefied cabbage has been known by competent physicists and chemists and chemical engineers, mechanical engineers, ever since the last quarter of the 19th century.
Why is that? Why do they know this?
Because the second law of thermodynamics prohibits it. Oxygen and hydrogen combine spontaneously to form water. Water does not spontaneously dissociate itself to form free oxygen and hydrogen. That represents an irreversible physical phenomenon. Mm-hmm. The laws which describe that irreversibility is a law particularly called the second law of thermodynamics. Now, unfortunately, in Britain and America, and I emphasize, when I say Britain, I mean Canada and Austria and all those places. In Britain and America, there is this bizarre fetish among geologists that they don't study physics and chemistry. And you can ask that of any man who sat through the basic courses in physics and chemistry at any university. Next time you hear some geology professor from America or Britain spouting off his mouth about oil coming from dead whatever, you ask him 2 questions. They're both significant to this point. The first question is, tell me, Professor, describe the university-level courses in physics which you took while you were studying. That's the first question. The second one is, tell me, Professor, how much oil and gas have you discovered lately? Mm-hmm. Rather significant now. What isn't in that article, which I wrote, was any description of the enormous quantities of oil and gas found by these men practicing the modern theory of petroleum, the Russians and what's the former Soviet Union, who discovered enormous amounts of oil and gas down in the crystalline basement, which is where what the Russians call the bio-boobies would tell you it's impossible to find oil and gas. What my article does, which should be understood, unfortunately, physicists and chemists who know better than this biological silliness have sort of allowed themselves to be cowed into silence, because when they were saying, no, oil doesn't come from squashed fish or putrefied cabbage because the laws of thermodynamics prohibit such evolution, they would then be confronted with, well, okay, you tell us where it does come from, blah, 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 and they couldn't say. Literally, the problem of describing in proper physical terms exactly how oil does evolve was only solved recently. That's the second part of the paper which you cited. Mm-hmm. So and the third part was a demonstration of that.
Yeah, by making it in laboratory.
Exactly. We made it in laboratory.
And let me see if I can take a call in here. Let's go to Paul in Kansas City, Missouri. Hi, Paul.
How you doing?
Hi.
Interesting topic. I've got a friend of mine who's a geologist who happens to stay with me while he works here in town for a company, and I taught him years ago in chemistry, just as an aside. Mm-hmm. But my question here is, you're talking about what calcium carbonate is being feedstock for this process, mm-hmm. And where does that calcium carbonate originally come from? What processes produce that in the earth? I was under the assumption that might be it composed of seashells.
Do you want me to answer that?
Yeah.
Right. Okay. First, when my colleagues we argued about this as to whether to use as the source of carbon calcium carbonate, or whether we should use just pure graphite initially. I argued for graphite because that is certainly going to be the more common form of elemental carbon at the depths of the mantle. However, they said that makes the problem too easy. We want to start with a real oxidized form of carbon, and as you know, as a geologist, well, I'm sorry, sir, I didn't quite. Were you the chemist, or with a friend of his a geologist, or are you the geologist?
I'm the ex-chemist, and he's a geologist.
Okay, well, good enough. As your geologist friend will then affirm for you, calcium carbonate of mantle origin has been observed in these geological formations called carbonatites, where by use of other isotopic tests, they've ascertained that some of these carbonatite formations are indeed of mantle origin. So there is calcium carbonate in the form CaCO3 in the mantle.
It's not non-biological origin.
No,
Yeah.
you can dispose of that right away.
Okay.
Because remember, no biological molecule can exist at the temperature higher than the critical temperature of water.
Right.
Strictly the critical temperature of salt water. That's not much difference. And the critical temperature of salt water is reached at a depth of about 3 kilometers, 5 kilometers, depending on whether you have the you're in a continental environment or marine environment. So the notion that the carbon material at the depths of the mantle might be biological of origin really has no meaning.
All right, okay, Paul?
Yeah, it's good enough.
What do you think of this theory?
It's interesting. I've heard similar things over the years, and the idea of a Manhattan-style project, I've been arguing that point myself with people about the current energy crisis, that we need a project of that level.
Get that man's name, please, moderator. I want to get back to him.
Yeah.
All
right, Paul, write him a letter. Read it in Nature, and you can reach Dr. Kenny in Nature there. Thanks for calling.
Excuse me, I direct call use the proceedings of the Academy of Sciences.
I'm sorry, you're right.
It's the point that I'd like to
Academy.
make.
Yeah, go ahead.
There are over 4,000 articles written in the mainstream Russian scientific press on this subject.
Mm-hmm.
And hundreds of books and many, many monographs. It's a scandal that essentially not one of these has ever been translated and published in, say, the Journal of Petroleum Geology or
so on
and so forth.
Let me see if we can get another call in here. I think we have a Russian geologist on one of our lines here. Let's see if we can go to that one. Let's go to Alan in Charlotte, North Carolina.
Yes, hi, Ira.
Yes.
Thank you for taking my call. I'm actually not Russian, but I went to school in the former Soviet Union, and I finished geology in the mid-'80s. And I would like to ask, is this new petroleum that has been artificially made, does it behave exactly the same under polarized light as the natural one? Because when we were in school, we had some artificial petroleum, and it did not behave, and I'm talking about optically.
Mm-hmm.
And
why is that important?
Because that's the way you can find out if it's artificial or natural, and different petroleum from different places
mm-hmm.
Actually behaves a little bit different under polarized light.
Dr. Kenny?
Yes. First, could I have the man's name again, please?
Alan.
And he mentioned he actually studied in the Soviet Union. Would he be willing to say whose student he was?
Dr. Kenny, I'm running out of time. I want to answer the question. I didn't get an answer.
Okay, the answer, first, for the question, there's the confusion about optical activity. Optical activity is not a measure of any biological origin. That point's been known since the 70s. The origin of optical activity and why purely constructed abiotic fluids produce optical activity has been completely described in an article in the scientific journal Physical Chemistry, Chemical Physics, year 2000, volume 2, page 3163, authored by J.F. Kenny from the Russian
mm-hmm.
Academy of Sciences and Ulrich K. Deiters from the University of Cologne. It's a long subject. It will take,
okay, well, let me move on.
The mistake is that optical activity is some evidence of a biological origin is completely incorrect.
All right, let me move on. You made that point. Let me move on to ask why if it has an origins that are not from biological origins, why do oil companies still successfully look for oil using that criteria?
Okay, first, as a man who has lived or died as an oil company looking for oil, they don't successfully
mm-hmm.
look for it using that criteria. The measure of exploration success
mm-hmm.
by British and American petroleum companies in the absence of seismic data, which
mm-hmm.
is so good you can see the oil on the ground.
Right.
If you don't have that, their rate of success is one commercial well out of 28 dry holes. As a study from the United States Geological Survey made clear about 15 years ago, the success rate of American petroleum companies is so poor that it is, quote, no better than random, unquote. In other words, these oil companies, they do as well to get an 8-year-old child to throw darts on a map on the wall as to hire an American geologist to tell them where to drill.
All right, let me interrupt and remind everybody that I'm Ira Flato, and this is Talk of the Nation Science Friday from NPR News. Yet you'd say you're having a difficult time convincing your colleagues, are you not?
Excuse me. I work with the Russian.
I don't mean your Russian colleagues. I mean your American colleagues or other.
I don't really bother to try to persuade them. I'm in competition with them.
Oh, in what way?
I'm an oil and gas driller.
Yeah.
And there's a wonderful quotation here. Sort of sums it up. At the International Conference on Deep Drilling in 1992, the academician Nikolaevsky gave one of the invited talks on petroleum and pointed out, including taking examples from American oil and gas fields, of the evidence of mantle origin fluids in the crude oil. And when he was through speaking, this young fellow sort of leapt to his feet and in a voice redolent with aggressive hostility asked, "Professor Nikolaevsky, don't you know that oil comes from biological detritus in the sediments?" Academician Nikolaevsky fixed him with a basilisk stare for a moment and said, "That is nonsense. In Russia, we have known for more than 40 years that petroleum is a juvenile material erupted from great depth." He paused for a minute, and while still fixing his eye on this young man, continued, "And I remind you that Russia is the largest petroleum producing and exporting nation in the world."
All right, let me get a quick question in before we have to go to Karen in Oregon. Hi, Karen.
Oh, hi. Thank you for taking my question. I don't know if that's the same gentleman you're still speaking with, but originally he said that you should ask him, whoever was going to spout off any kind of theory, how much oil and gas he had exactly discovered himself.
Right.
And I didn't hear that. Now I may have missed it.
Well, let me ask Dr. Kenny, if your ideas are right about where this is coming from, are you much more successful in this, as a driller in discovering oil?
Well, this is a wonder. I love this question. Someone throws it back in my face. I even try to say, well, don't you really mean...
I got about 20 seconds.
Okay. During the past 10 years, working in collaboration with V.A. Kryushkin of the Academy of Sciences, we've brought in a series of oil and gas fields on the northern flank of the Dnieper-Donetsk Basin, greater than the entirety of the reserves in Alaska.
Wow. All right, you've got the last word.
Yes, sir.
Thank you very much.
The Russians have the last word. Please get it right, sir.
All right. J.F. Kenny is CEO of the Gas Resources Corporation in Houston, Texas. We're going to take a short break, and when we come back...